Hello children. Trigonometry deals with the relationship between the sides and angles of a right-angled triangle. It is one of the oldest branches in mathematics. The concept of trigonometry was given by the Greek mathematician Hipparchus. He was a geographer and astronomer as well. He was the one who used trigonometry in studying the orbits of the moon and the sun in those ancient before Christ days. He is termed as father of trigonometry. We have enormous applications of trigonometry in our daily life. For instance, we can measure the height of building or a mountain without climbing on it using trigonometry. This is a right-angled triangle ABC with angle B is equal to 90 degree. For angle A, AB is the base or adjacent side and side AC is the hypotenuse. For angle C, BC is the base or adjacent side and side AC is the hypotenuse. So, in right-angled triangle, for a given angle, the side opposite to the right angle is called hypotenuse. The side opposite to the angle A is BC, called opposite or perpendicular side, and the side opposite to the angle C is called AB. So for angle C, AB is the opposite or perpendicular side. There are 6 trigonometric ratios used in finding certain angle theta of a triangle. Don't worry about theta, it is just a Greek alphabet used to denote unknown measure of an angle. The 6 trigonometric ratios are sine, cosine, tangent, cosecant, secant and cotangent, abbreviated as sine, cos, tan, cosec, sec and cot respectively. The ratio of the sides of the right-angled triangle are related to the angles as sine theta is equal to opposite side by hypotenuse and the angle cosecant theta is reciprocal of sine theta. Therefore, cosecant theta is equal to hypotenuse by opposite side. The angle cos theta is equal to the adjacent side by hypotenuse. Secant theta is reciprocal of cos theta. That's why it is hypotenuse by adjacent side. Now we have tan theta which is equal to sin theta by cos theta. That's why it is equal to the opposite side by adjacent side, and we have cot theta which is the reciprocal of tan theta. That's why it is equal to adjacent side by opposite side. The mnemonics to remember the definitions of trigonometric ratios is SOH, CAH and TOA. You can call it SO, Ka, Toa, which you can remember as some old hippie caught another hippie tripping on acid. You can have fun playing with your friends by taking it as a tongue twister and hence memorize it. Now, let us have a right-angled triangle ABC with angle B is equal to 90 degree and angle A is 45 degree. Then angle C will be 90 minus 45 degree which will be equal to 45 degree again. That means angle A and angle C are equal. Let the two sides of this triangle AB and BC be equal to 1 unit each. Then you can apply Pythagorean theorem and find the hypotenuse AC. So we have from the Pythagorean theorem AC is equal to square root of AB square plus BC square. Substitute the values of AB and BC as 1. Then you can find the value of AC as root 2. So we have the hypotenuse here equal to root 2. Now find sin theta. Here theta is 45 degree and we know that sin theta is equal to opposite side by hypotenuse. That's why we can write sin 45 as 1 by root 2. We know that cosecant theta is the reciprocal of sine theta. That's why we have cosecant 45 degree is equal to root 2 here. Also, cos 45 will be equal to 1 by root 2. And the secant theta is the reciprocal of cos theta. That's why it is root 2 again. We have tan theta. That's why tan 45 degree is equal to sin 45 by cos 45, which will give us 1. We have cot theta, which is the reciprocal of tan theta. So we have cot 45 is also 1. Here we have 45 degree is equal to 90 minus theta, or theta is equal to 90 minus theta. That is, angle A is equal to angle C. Therefore, I can say that sin theta is equal to cos of 90 minus theta, because sin 45 degree and cos 45 degree is equal to 1 by root 2, which is the same value. And I can also say that secant theta is equal to cosecant of 90 minus theta, because cosecant 45 and secant 45 degree are root 2, which have the same values. And also tan theta is equal to cot 90 minus theta, because tan 45 and cot 45 have the same values, which is 1. These are known as complementary angles because they are less than 90 degree. One important rule is that sin square theta is equal to sin theta whole square, and it is not equal to sin theta square. That means the square doesn't come inside the angle. Trigonometry consists of many identities which you will have to memorize. As you go from one class to another, the number of identities will increase. We will now discuss few basic identities called Pythagorean identities, and also see how they have derived, so that it will be easy for you to understand how can you play with the trigonometric ratios. First one is sin square theta plus cos square theta is equal to 1. So this is an identity. It is a rule. It is always that sin square theta plus cos square theta will give you 1. 1 plus tan square theta is equal to secant square theta. And the other one is 1 plus cot square theta is equal to cosecant square theta. Sin square theta plus cos square theta is equal to 1 means you can have any value of theta, say 45 degree. So sin square 45 degree plus cos square 45 degree will be equal to 1. This is what the identity says. We can derive this Pythagorean identity very easily using the Pythagorean theorem. AC square is equal to BC square plus AB square. Divide the equation by AC square. Then your AC square will get cancelled by AC square on the left hand side and you get 1. Then BC square by AC square will give you sin square theta, and AB square by AC square will give you cos square theta. That's why sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta means you can have any value of theta, as I said earlier. So here let me take as 45 degree. So when I take 45 degree, I mean to say that 1 plus tan square 45 degree is equal to secant square 45 degree. So to prove this identity, take the Pythagorean equation again. AC square is equal to BC square plus AB square. Divide the equation by AB square both sides, which will give you AC square by AB square, which is equal to BC square by AB square plus AB square by AB square. AC by AB will give you secant theta The square of it will be secant square theta. BC by AB will give you tan theta, and AB will cancel with AB, which will give you 1 plus tan square theta is equal to secant square theta. Now to prove this identity, 1 plus cot square theta is equal to cosecant square theta, take the first identity, that is sin square theta plus cos square theta is equal to 1, and then divide this equation by sin square theta. Then you get sin square theta by sin square theta, which is going to cancel. Cos square theta by sin square theta, which is the reciprocal of tan theta, remember, that will be your cot theta. And then that is equal to 1 by sin square theta, that means the reciprocal is cosecant theta, which will give you 1 plus cot square theta is equal to cosecant square theta. This is how we do in terms of theta. But when you have the values given, like for example 45 degree is given here, so you can easily substitute their values anytime and just find the answer. We have sin 45 as 1 by root 2, cos 45 is also 1 by root 2. So just substitute them. 1 by root 2 whole square plus 1 by root 2 whole square will give you 1 by 2 plus 1 by 2, which is going to give you 1. So that's the answer. And then 1 plus 1 square, because tan 45 is 1. So 1 plus 1 square is going to give you root 2 whole square. And see here, secant 45 is root 2. So squaring of that root 2 will give us secant square 45 degree. Same thing can be done here. 1 plus 1, we know that cot 45 is 1. So 1 plus 1 square is going to give you root 2 whole square. That means you are getting cosecant square 45. Degree and radian are the two units to measure the angles. We have pi radians is equal to 180 degree, which is equivalent to going halfway around the circle. We use 180 by pi as a conversion metric because 1 radian is equal to 180 degree by pi. And 360 degree is double of 180, so you will get 2 pi in radians. We can depict these standard values in a unit circle with 4 quadrants. Now we are ready to memorize few standard trigonometric angles with degree and radians. Let us start with for 0 to 90 degree. We have a trick to memorize these values. So from 0 to 90 degree, just write down root of 0 by 4, root of 1 by 4, root of 2 by 4, root of 3 by 4 and root of 4 by 4. That is, write 4 in the denominator and write 0, 1, 2, 3, 4 respectively in the numerator from 0 to 90. And then just write down the values which you are going to get. For 0 by 4 you get 0. So that's why your sin 0 will be 0. For root of 1 by 4 you are going to get 1 by 2. That is sin 30 will be 1 by 2. So root of 2 by 4 you are going to get 1 by root 2. That's why sin 45 is going to be 1 by root 2. For sin 60 you get root 3 by 2. And for sin 90, 4 and 4 gets cancelled, you are going to get 1. Now to find the angles of cos, just reverse these values of sin and then write down 1 root 3 by 2, 1 by root 2 as it is for 45 degrees, then 1 by 2 and 0. So these are the values of your cos. See how easy it is now to remember also. Now we have tan theta, which is equal to sin theta by cos theta. Just divide them. Divide sin by cos and write down the answers. We have 0 by 1 will be 0. 1 by 2 divided by root 3 by 2 will be 1 by root 3. 1 by root 2 divided by 1 by root 2 will be 1. Root 3 by 2 divided by 1 by 2 will be root 3. That is tan 60 will be root 3. Divide 1 by 0 for tan 90. We know that 1 by 0 is not defined. Note that this sign on the trigonometric ratio depends upon the quadrant. See here from 0 to 90 degree, there is no sign. That means there is no negative sign. All are positive values ranging from 0 to 90 degree for sine, cos and tan. The reason for this is that in the first quadrant, all the trigonometric ratios are positive. In second quadrant, sine theta and cosecant theta are positive only. When I say that sine theta and cosecant theta are positive, I mean to say that all other trigonometric functions are negative in the second quadrant. And in the third quadrant, tan theta and cot theta are positive. And in fourth quadrant, cos theta and secant theta are positive. How do you remember this? You have mnemonics for that. After school to college, or all silver teacups. So all means in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only sine and cosecant sine, which is the reciprocal of the sine, are positive. In the third quadrant, only tan and cot are positive. And in the fourth quadrant, cos and secant are positive. Now we know that certain trigonometric ratios are negative in certain quadrants. Based on this, we can find remaining angles from 180 degree to 360 degree. Sine is positive in first quadrant and second quadrant. Therefore, sine 270 will be -1, but sine 180 and sine 360 will be positive. But remember, sine 0 will be equal to sine 180 because they lie on the opposite side of a straight line. And sine 180 will be equal to sine 360 because they also lie on the opposite side of a straight line in a circle. And therefore, the values will be same for sine 0, sine 180 and sine 360. This is going to happen for all the trigonometric ratios. Cos is positive only in first and fourth quadrant, therefore it will be negative for 180 degree, or for angles greater than 90 degree and less than or equal to 180 degree, the cos theta is going to be negative. Tan theta will be positive only in first and third quadrant, but we know that tan theta is equal to sin theta by cos theta. Therefore, for 270 degree, tan theta is equal to -1 by 0, which is not defined. You can now easily find the values of cosecant, secant and cot theta for the value of theta ranging from 0 to 360 degree. I leave this work up to you. What you have to do is just find the reciprocal of sine, cos and tan for cosecant, secant and cot respectively. I hope this video will make trigonometry easier for you, and do let me know your feedback in the comment section, and do subscribe this channel for future updates. Thank you. Bye.